Hi friends, welcome to my channel. Let's have a look at problem 2548, maximum price to fill a bag. In this video, we're going to share or explain a solution based on sort with specified key, and also we do greedy filling. First, I'll read through the problem statement, and then we look at one example, and finally we share the codes. First, the problem statement. We are given a 2D integer array called items, where items equals price and weight. So it denotes the price and weight of the ith item, respectively. So we are also given a positive integer called capacity. So each item can be divided into two items with ratios part 1 and part 2, and then the price and weight are partitioned accordingly, partition according to the proportion. So here we are required to return the maximum total price to fill a bag of capacity with given items. If it's impossible to fill a bag, we are going to return -1. So the answers within this this precision of the actual number or answer will be considered correct. So here are two examples. So in example 2, so here the total weight is 30, but the capacity is 50. So the bag cannot be fully filled, so we return -1. And in the second one, in the first one, so we can use the whole item 1 and then use 1/2 of the item 2. So the total price is 50 plus 5, that is 55. So before we look at the analysis, let's also look at the constraints. First, the length of the list items is bounded above by 10⁵, and each item's element contains price and weight. So the price and weight are bounded below by 1, in other words, positive. And the capacity is also positive, so but it's bounded above by 10⁹. So with that said, we are ready to look at the analysis. So here we are going to use sort. So again, with customized keys. So here we need to sort the elements in items with price over weight ratio from high to low. Right? We want to first fill the bag with the items with higher ratio, so that we can maximize the total price. So here first let's make a observation. So if the weight sum of all the items is less than capacity, so we're going to return -1, because there's no means of filling fully the bag. So otherwise, so we're going to fill the bag with high ratio weights to full. Here is an example 1, right? So this is the original given list, and the capacity is 29. So if we sort according to the price over weight ratio, so we're going to have such an order. So we're going to regard this one as item 1, item 2, item 3, item 4, or 0th item 1, first item. So we're going to use, let's examine the capacity. So we're going to use 5 of these, and then 19 of these. So 5 plus 19 is 24. So then we can use 5 more. So we can use 5 out of 9 of the third item. So that is corresponding to index 2. So then the capacity will be 0. Then we have filled the bag fully, right? So we don't need to use the last item in this specific example. So the total price is 15 plus 17 plus, this is the total price, but we used 5 out of this 9. So we get 5 times 5 over 9. So this is the final result. So with that said, let's look at the coding. So first, I'm going to write a very verbose solution based on above analysis. So I'll call this one V1. So essentially we use two loops. First we compute the sum of the weights and then compare it with the capacity. If the weight sum is less than the capacity, so we are going to return -1. And then we do the fitting. And the second version will be directly do the fitting and also simultaneously do the check. So this is the V1. It's a two pass essentially, right? So first I'm going to do the sort according to price weight ratio. So we're going to sort from high to low. Right, so this is easily done. So we can do it in place. So we pass a callable. So let's call it this lambda function. Lambda. So here this is the item. So we're going to, this is the ratio, right? X0 over X1. And then we're going to sort reversely. So we'll use a negative sign here. And then this achieves our goal. And then first let's do a check, right? So a check. So if sum of the weights, so for X in items, right? So if this is less than the capacity, so we're going to return -1. In other words, there's no way to fill up the bag fully. So thirdly, so we fill the bag greedily. So for this, I'm going to initialize a result variable, initially 0, and then we iterate. So for price and weight in items, right? Then we're going to check if the weight is larger than or equal to items. If so, so we are going to not items. So here is capacity. So this capacity I'm going to use as a variable. In between, we are going to update it. So if the weight is no less than the capacity, so means that in this, when we see this one, we already can fill the bag fully. So in this case, the result increase is the portion, right? The price. This is the total price times the portion. The portion is the capacity over W, and then we just break. So actually we can just return. So this is the one. Another one is that, so if the weight is less than capacity, it means that the current bag, if we use all its weight, we still cannot fully fill the bag. So we need to first add the price, and then we are going to decrement or update the capacity by that of the current weight, and finally we return the result. So this is one solution format. Before we do any comments, let's first do a check. Yeah, it passes a test case. So now let's look at the generic case. Yeah, it passes all the cases. So here, actually we have already done, because we have checked this -1 case in the second step. So here, actually, we can just return results. So let's do a check. So this is the one version of solutions. So, but here, essentially, when we do the check, we need to sum all the weights. So this is one pass. Here, the for loop is another pass. So let me copy this function and change this one to be V1. So let's modify the code so that we can do using a single pass. So here, this is a V2. So now let's use a single pass. So this part does not change, right? So now we directly filling the bag greedily and also check, right? So for this, let's first do this, and then what we are going to do. So if we are here, right? So we actually directly return the result. And then otherwise, so we are going to do this results plus. So then this is the one, but we need to adjust the return, because it's possible that after we iterate all the items, so the capacity is still positive. In other words, it cannot be reduced to be 0 or less than 0. Strictly speaking, it's reduced to 0. So in this case, so if capacity is 0, so we're going to return result. Otherwise, so we return -1. So this one, this way, so we just need a single pass. So with that said, let's first do a check. Yeah, it passes all the cases. So I guess that's about it for this specific problem. So here the main point is that, so we do the sort with a customer key, and then we fill the bag using some greedy sort. So with that said, I guess that's about it for this specific problem. So you are welcome to check out other videos in my channel. With that said, thank you.